Here. So thank you again for joining us for another Autodesk Design and Make webinar. This is, of course, a series for educators like all of you, and it's so fantastic to see so many of you joining us again this afternoon or morning, wherever you are in the world. And tonight is all about engaging students through robotics education, which is a really diverse topic, so we have loads of things to talk about. My name is Jason Erdreich. I am a technology and engineering educator, and I've, of course, teamed up with the Autodesk and Tinkercad teams to provide resources like this webinar to all of you. And I'm joined by a new co-host this evening who's normally in the background, but she's taken center stage with me here. Nicole, if you want to say hi.
Hey, I'm Nicole, and I do community support for Tinkercad and Instructables, so I get to see all the amazing things that people are making and designing, and it's always fun to see what everyone is up to.
Yeah, it's fantastic. So Nicole's always the one that's working furiously to answer all your questions in the chat. I'm sure she'll continue to do that tonight, but it's great to have her as a co-host with me. I also don't know if you recognize her Instructables username, but she's a pretty famous maker there. So it's a pleasure to have her here with us. And we also have Darren behind the scenes and usually a couple other Tinkercad/Autodesk team members join us throughout the evening. So a big shout out to all of them for helping support Tinkercad and the Autodesk community and allowing these webinars to run so smoothly. So thank you all for being here. And again, tonight is all about robotics. But if this is the first webinar, I want to talk a little bit about the Design and Make series. This is our, I think, fourth or fifth webinar that we have going on here. We've been doing a number, and we have a couple more. It is the fifth one. I just checked, so it's the fifth webinar. And we have a few more before the end of the year, which you can check out the remaining webinars on our blog. All of these webinars are recorded, so I'm sure we'll be able to drop a link in the chat in just a second here, so you can always go back and check out the past Design and Make webinars, as well as the ones that we've done earlier in the year, like the Teaching with Tinkercad series and the Level Up with Fusion series. All of those are on the Autodesk Tinkercad's YouTube channel that you can check out. And looking ahead, our next one is going to be called Design and Make with Lasers, which will be later this month. Same place, same time. So in 2 weeks, we'll talk about lasers. But again, tonight is all about robotics. Now, we're going to drop a poll on your screen right about now, so you should see a poll coming up any second. And I know a lot of you said this in the chat, but we'd like to learn a little bit more about the subject and grades that you teach. So if you could just take a second to answer that poll, that'd be fantastic. I know robotics is an incredibly diverse topic to be teaching to our students, and I've also personally taught robotics K-12 and at the college level, so I know that it's something that can be differentiated and modified for pretty much any age group. So I want to get a sense of where you're coming from in terms of the disciplines that you teach, as well as the grades that you teach, and we'll try to cater those conversations specifically to you and your students and your needs based on that age group there. So I'll give it just another second. I see a lot of answers coming in. Thanks so much for taking the time to complete that. So I'm seeing a lot of folks, or most of our attendees are from like the technology or engineering space, but a number of you are from science, art, and other subjects as well. And I think the majority of our attendees are looking like we are from the elementary school and middle school space. We have a number of high school and university colleagues with us as well. So thank you all for being here. That's hugely helpful. So it looks like we have a super diverse group, which is great because, of course, we have such a diverse topic. Now, we're going to be going through things very quickly, because of course we only have an hour to cover as much as we can about this topic here. So a couple key things if this is the first time you've joined us. First and foremost, you'll notice the chat moves super fast. You can always drop questions in the chat, and we'll be working to drop links in the chat to support you throughout this webinar. But I want you to use that Q&A button whenever you have a question that you'd like to be answered. So that's a Q&A button on your Zoom toolbar, because you can ask a question and that question will remain until somebody from the Tinkercad Autodesk team with me here answers it. So it's much easier for us to see your questions, and it's also easy for attendees to also see the answers to those questions. And again, this Zoom is being recorded, so we will share a recording out with you in the next day or so, along with a bunch of other resources. The slides that you see will be shared as well, so you'll see some hyperlinks in the slideshow. We're going to email that out to all of you in the next day or so. So please keep that in mind, that we know we're going through things kind of quick, but we're going to follow up with a bunch of takeaway resources as well. And there also will be time for Q&A at the end. So Design and Make, we brought up this webinar and we shifted from the Teaching with Tinkercad and the Level Up with Fusion series to the Design and Make webinar for the second half of the year, because we are so excited about all the incredible things that our students are making and that everyone's making throughout the Autodesk community. I mean, students are making things like robots or programming circuits or Rube Goldberg machines or vases, and it's just such a diverse group of individuals that we have working with all of the Autodesk resources like Tinkercad or Fusion. And it got us so excited about how broad the subjects can be. So really, we want to be able to meet with educators like all of you, talk about some exciting concepts and things that you might want to bring into your classroom, and then provide you with the resources and support to be able to do that. And of course, tonight is all about robotics education. So we'll start by just defining what is a robot, and it's essentially a machine that can perform actions autonomously or on its own, either by following a coded program or by making decisions based on its environment. So perhaps it has some type of sensor, so it can read, let's say, temperature or distance or something around it, and then based on that input from a sensor, whatever it is, it can make a decision. And I love to point out whenever I teach this to students that robots come in all shapes and sizes. So we often think of, maybe because of all the sci-fi movies and video games around us, a robot that might walk and talk like a human, or maybe roll on the ground and make fun little beep sounds and things like that. But robots can be many different things, and we use robots for many different things in many different industries. Manufacturing is very much dominated by robotics in terms of how things are made at mass scale, and automotive design, and even some smaller electronics and things like that. Or we use robots to be able to speed up that process and support humans as we manufacture things. Robots are also used very much in the medical applications and scientific research through surgery and things that might be difficult for humans to do. Robots are used for construction and public safety, to survey, to inspect, to help first responders. And of course, there's plenty of robots used in consumer technology, like our little robot vacuums. But again, I like to point out to my students that robots, again, as a machine that can do something autonomously, means that sure, it can look like a robotic arm or a drone or a little robot that rolls around on our floor. But you could also define an air conditioning unit as a robot. If it can automatically measure the temperature in the room and identify that it's too hot, and then it decides it should turn on and cool the room off, I mean, that's an autonomous system that was able to do that. So when we bring that up, and the fact that robots do come in many shapes and sizes and are used in so many different applications, us and as educators can realize that, hey, there's so many opportunities for bringing this into our classroom. So if you teach science, you can bring in science applications. If you teach technology or engineering, we can talk about manufacturing. If you teach architecture, we can still talk about robotics because it's used so much in construction technology, which is really exciting. It means that there's so many real world connections we can create with these topics. And when we do this, when we bring this into the classroom, where we allow students to try to identify these things and design and build their own robots, it's done through a very engaging and hands-on learning experience where they get to use other resources like maybe 3D printers or computer programming software, things, many of which we'll talk about tonight, to actually design their own robotic solutions that look like the ones that we might be using in these future careers, and that might excite them. It might make them want to engage with those careers, which of course is something we want to inspire as educators. And there's many different forms, right? So there are plenty of robotic kits and things like this that you could actually purchase and bring into your classroom and students can build with and interact with. And there's so many different versions out there. But I also like to point out that we can engage with these conversations within the screen, right? So I work with a lot of schools that might not have a space or a budget to be able to bring in very big, expensive kits. And that's a challenge that maybe many of you experience as well. But getting students to think about robots by maybe designing one that's on the screen and being able to interact with it and establish how it works is a really powerful skill for allowing them to connect with these careers. And what I'm describing is really teaching through a design process, identifying that robots are used to solve problems, whether it's keeping our houses cool or saving someone's life or checking to see if a building is safe. We're using robots in many different industries to solve problems. So if we challenge our students to think about robotics by designing a robot to solve a problem, like, for example, designing a robot to help people or designing a robot to deliver something, it allows them to not only gain understanding of robotics and computer science, but also strong problem-solving abilities and collaboration abilities. And we talked quite a bit about this in our last webinar, which was all about teaching with sustainability, about how challenging students to engage with real-world problems in the classroom is a very exciting and engaging experience for them to do. And to support you with this, we have a couple exciting lessons. I'm not sure if you've seen the Tinkercad lesson plans, but there's a number of them posted on the Tinkercad site, which I'm sure we'll have a link shared with you in just a second here. And one lesson that really stuck out with me that I want to include in this slideshow is designing a device that can move through a pipe. So it presents a problem to students where perhaps there's a pipe in our city that's broken or clogged or needs to be accessed for whatever reason, and students are challenged to use Tinkercad to design some type of robot that can move through this pipe. And this is a real world challenge, right? So there are actually robots that survey pipes and can do these things and even build pipes and weld pipes. And it allows students to not only engage with robotics, but potentially a big real world problem through a design process to be able to do that. So a very relatable and relevant thing for them to engage with in robotics. There's also a lot of other lessons, not only from Autodesk, but all throughout the Tinkercad and Autodesk Instructables community. So MC Langer is one of our Tinker stars and a really fantastic Instructable user who has a whole Tinkercad Robotics for School series of lessons and things that I would definitely recommend you check out. You might even notice that some of the shapes that he created are in Tinkercad that we'll take a look at later today. So there are so many great design challenges where, again, students can engage with robotics and bring those ideas into the real world. So lots of really creative solutions and things for students to engage with at really all levels, whether it's elementary, middle school, high school, very exciting concepts and things. So there's so many that we can talk about, including robotics education competitions too. So there are plenty of competitions. It might vary on your region, right? So First Robotics, which is something that Autodesk supports, and we have a lot of teams that use Fusion 360 for, and we'll talk a little bit more about that later tonight, is a huge global competition that challenges students to design robots to solve problems. And there's different levels depending on the age. There's elementary, middle school, high school, and even collegiate competitions that students can engage with. That allows them to work collaboratively, design, test, and compete with robots they build. But there's a lot of other ones as well. Depending on where you are in the world, there's plenty of robotic competitions and things that might be available to you if you want to bring that real world and collaborative experience into your classroom as well. Not that it's required. I personally coached teams in FIRST and in other competitions like the REC here in North America. But I've also taught robotics for a number of years without having a competition team, and still just bringing these concepts into the classroom is a very engaging and worthwhile experience. So now that we've kind of given an overview of what robotics is, let's kind of talk about how students might actually design a robot or be able to do this. We can break a robot into subsystems, and realistically, there might be hundreds of subsystems depending on how detailed we want to go. But we can talk about two primary subsystems that a robot needs in order to do its job. And there's the mechanical subsystems, like how does a robot move or physically do something? And then there's the electronic subsystems. What are the wiring and the motors and the power and maybe the code that actually makes it function? And to have a successful robot, you typically need to consider both things, right? And of course, we can narrow this down even more, where maybe within electronics, there's sensors and motors, and maybe in mechanics, there's a chassis and many mechanical parts, but we can just kind of keep it broad for now. And depending on the age group of your students, as well as their prior experience, I would recommend that you consider using Tinkercad and or Fusion for students to be able to design these subsystems. Tinkercad being a fantastic introductory program to students of all ages as they're just starting to learn how to use CAD or computer-aided design to be able to actually design and manufacture their ideas. And Fusion is really for more advanced students or older students, and it varies a little bit depending on region, as we'll talk about, that allows students to take these concepts and elevate them to real-world career connections as well. So we'll be talking about both of these tonight. But just to give you a little overview, because I saw that there's so many new folks here with us, both of these programs can be accessed in the web browser on pretty much any device. So you can just open it up in the browser, as well as Tinkercad offers an app for tablet devices, and Fusion also offers an app for Windows or Mac devices. So you can access these programs on a lot of different devices. Both of these programs can be accessed for free. So Tinkercad is free for everybody. So anyone can just go to tinkercad.com, and students and teachers can either create a free account or sign in with a supported account from another provider, like you can see on the screen there. And Fusion is free for education. So you as a teacher and your students can gain access to Fusion for education. But as I mentioned, there's age restrictions depending on the region. So in North America, for example, it's 13 or older, but that might vary depending on where you are. Classes and teams. So this is something that we're not going to be able to talk about too much in tonight's webinar, but I do recommend you go back and check out past webinars to learn more about it. In Tinkercad, teachers can create a class to invite students to and to be able to organize their work and also be able to support students by leaving feedback and seeing what they're creating. And similarly, in Fusion, there's something called teams where teachers can create teams and again allow students to organize their projects, collaborate with one another. For example, they can share and invite students to kind of see their other projects and things. So really great opportunities to be able to support a class in either one of these programs. And then within each program, there is a number of spaces that students can design in. And we'll be talking about a number of them tonight because robotics is so broad. So in Tinkercad, we can create 3D designs, we can create circuits, and we can create something called code blocks. And I'll show you a little bit about designing 3D design and circuits. We won't talk too much about code blocks tonight, but it's a fantastic way to engage with computer science to make 3D design. And again, it's something we've talked about in past webinars I recommend you check out. And Fusion, again, bringing in a lot of career connections and things, allows students to create 3D designs, preparing designs for manufacturing, working with electronics, simulating their designs using generative design, which is a way for the computer and artificial intelligence to actually help us optimize our designs as well. And then, of course, working with collaboration, as I mentioned before. So there's a lot of spaces in these programs that make both of them suitable for designing robots, but also make them a worthwhile resource for you to consider for just all the other amazing things that you do. And again, tonight I'll try to show as much as I can, but we certainly won't be able to cover all of it. There's also a really great feature where students can easily send their designs from Tinkercad to Fusion if they get to a stage where they can't progress past a certain point or they need certain tools to finish their design that Tinkercad doesn't have, and they want to access those career and advanced tools in Fusion. There's an easy way just to send a design from one to the other, and we'll look at that tonight as well. And the reason you might want to consider doing this and why might you want your older students or high school students to elevate their skills to Fusion is, again, to bring in those career connections, to allow them to engage with all these different things. So when they are thinking about robotics, they're thinking about it just like the people that actually design our robot vacuums and our air conditioning units and manufacturing systems, the same types of tools that they use. We can bring those into the classroom by getting our students to learn through Tinkercad and elevate and level up their skills to Fusion when they are ready to do so. So they can kind of design the whole product. But that said, that was our introduction here. And let's get hands-on with designing some mechanical systems. And as I'm going to demonstrate a lot of these things live, I just want to let you know that in the slideshow, I kind of have these little slides with links and things that we'll be dropping in. And again, we'll be sharing this slide with you in our follow-up email. So you'll be able to access all these things, even if I am sharing it live here. There's plenty of things behind the scenes that you will be able to see as we follow up. So at the moment, we are looking at my Tinkercad here, and I'm just going to make a new 3D design. So this is where you could design within those three spaces I mentioned before. And 3D design is a fantastic tool, of course, to create 3D models in our design here. So the way that Tinkercad works is you essentially have these basic shapes that you can work with, as well as a number of other shapes that we'll take a look at in a little bit. And I can grab any of these shapes and I can manipulate their size by dragging these little handles. Or if I knew the size of something that I wanted, let's say I want to make something specifically 30 millimeters by 30 millimeters, I could actually type in those dimensions and actually set that to be very accurate as we design here. And you can adjust your unit that you want to work in, as well as adjust your work plane and things like that with all these different settings. So you can customize that as you'd like. And what I can do is I can combine different shapes. So I could, for example, create another cylinder, like this one you'll notice is a whole cylinder. And I can drag that over here. And if I select both of these shapes, you'll notice I have shapes 2 selected. I can use other tools like the align tool to make sure that they are perfectly centered like this. And when I then press this group button, what happens is that the whole shape cut into the solid shape. So we see I have a whole shape, a solid shape. When I group them together, it actually cuts out that hole, which is really cool. So while we look at these basic shapes, it might be kind of difficult to understand exactly what you can create. But really, your students, as they learn how to use these skills, they learn how to design in CAD and add shapes like I'm doing now, they can really make just about anything, any type of part as they design and fabricate as they go here. So now I'm adding a box shape to this. I'm thinking I'm designing some type of grabber or part some type of linkage for my robot is what I'm kind of considering right now. I'm sort of making something up on the random fly here at the moment, but maybe I want to just use some basic boxes, and I can not only change the size of my shape, but I can rotate my shape like this and sort of combine them together to have a group. And I see that we dropped the link in the chat, and there's plenty of links in the slides to help you learn these skills and gain additional skills and abilities as you learn how to use them, as well as provide your students with resources so they can learn how to use them as well. Now, I mentioned that there's a lot of shapes that you can use. So there are not only the basic shapes, but there are electronics and things that you can use, which are cool. And there's even everyday objects. So let's say, for example, I wanted to challenge my students to design a gripper for their robot that could hold a water bottle, right? So I can actually grab this model of a water bottle, and I'm going to scale my design up here a little bit. And maybe, let me just move this out of the way. Maybe I can add something on this gripper to make it a little bit more grippy, if you will, be able to get a little bit more traction on our robot. So I can just keep adding shapes and maybe copy this shape a couple times, give myself something that looks like this. Okay. That might be able to grab onto this water bottle. And of course, I might need two. So I can copy and flip this around. And perhaps if I actually install this on my robot, we'd be able to grab this water bottle, prototyping, something like that as we're designing from these shapes as we go. And if students wanted to export this, let's say for 3D printing, they could hit export and they could download it as one of these 3D printing files. We can also send it to Fusion, which we'll do in a minute. And next week, or not next week, in the next webinar in 2 weeks, we'll talk about what this laser cutting button does as well. Now, there's something else really cool, or there's a couple more cool features in Tinkercad in the 3D design space. I'm going to delete the water bottle for now, that you might want to consider. Like, for example, let's say that your students are working with little plastic brick toys that might look familiar to you, and they want to design a part. They can actually simulate on how they might design that part using these plastic bricks if they have access to that. So we can actually see how I might want to design these grippers using these bricks here, which might be super exciting and something to engage with if that's the type of robotic system that you're using, which is super cool. And there's also something called SimLab. So let's say that I actually designed something using that should have motion. So here's another design I created. These are gears that in theory should spin and turn one another. And I've created them in SimLab, meaning that I can actually simulate real world physics and motion. So I can actually set these to be different materials. And I've set these center drive shafts or dowels to not move, so only the gears can move. And what I can do is I can run my simulation and then maybe just throw something at my gears here and see, let me get in a better angle, see if I can actually make them turn and spin. So if we're designing parts for a robot that we want to test motion, we can do that too in SimLab, which is super cool and something that we've talked about again in past webinars, which is super exciting to take advantage of as well. And also, as we're designing robots, I just want to bring your attention to the objects one last time. You might find in the electronics objects that you might be using to build a robot. So for example, you might find a scale DC motor or a scale Arduino, and we can't program that here. That would happen in circuits, which we're going to look at in just a second. But these are scale models that we could actually use to design our robot and create maybe a chassis of some kind. Like, for example, let's say I actually knew that I was going to be using this servo motor to control my arms here. I could actually design this arm so that it was the right size to attach to this motor. And I wouldn't 3D print the motor, of course, I might already have that, but I would actually download this part and I would download it knowing that it would fit because I designed around it, which is super helpful for students who are a little bit younger, just getting started. Designing to a perfect scale or using measurements can be a little challenging at first. So having these parts in Tinkercad to work with are super helpful as we design our robots. So let's talk more about this send to fusion feature, right? Let's say that I design this and perhaps I want to be able to elevate my design a little bit, add some complexity to it that I can't achieve in Tinkercad, or maybe I'm a teacher that has older students that I want to them to start learning the more career skills. that they can bring into their industry that they might consider. So we could use this Send to Fusion button, and I can send it to Autodesk Fusion. I can rename it like sample Ripper if we want. If I was part of a class, let's say that I invited students to a team that I created, which I'm not in this account, I could actually send it specifically. So I might be part of a team called like Mr. E's period 2, and I could send it directly to that if I wanted to. I'm actually going to send it to Fusion on my desktop here. Let's see if this might just take a second for me to share with you. And then I'm going to stop sharing and just switch my screen to Fusion once I have it. Give me 1 second. Okay, let me share my Fusion screen. And now we can see my Tinkercad part imported directly into Fusion, which is super cool. So this is actually something that's going to be, we have some new features coming out, so stay tuned because the Tinkercad and Fusion team have been working to improve how easy it is to do this. So for example, when students bring their models in very soon, they'll be able to see that there's different parts and actually click on the parts that were used and be able to interact with it. So keep an eye on the Tinkercad blog because I know there's a lot of new exciting things coming. But with this part that I've imported into Fusion, we can do some things. We have all these tools here to work with. And if my toolbar looks slightly different than yours, if you have a Fusion program that you use, I just customize these things. So there's many tools that are hidden. And if there's a tool that you use really frequently, like for example, making spheres, you can actually pin that to your toolbar. So that might be why you see some different buttons on my screen than yours. You as a teacher might want to challenge your students to actually set up their Fusion screen to work like it is as a class. So you might actually on the first day of Fusion have them go in and customize. I know that we have some great resources on how to customize your Fusion document. So let's say, for example, that I designed this part and I want to change the diameter of these holes at the bottom, right? I want to change those. I could, for example, use this little press pull feature to click on these holes and manipulate the size nice and simply like that. So I could increase the size of that, and I suppose I could do the other one. That would make sense if I increase the size of this one as well. So that's pretty easy to do. Likewise, you'll notice that I didn't do really a great job at aligning these parts with my gripper. So maybe I actually want to press pull on all of these parts and just get them to line up a bit more accurately there because I didn't do such a great job in Tinkercad, but that looks a little bit better, which is good. So I can fix that. Then there's other tools that we have. Like for example, we might want to add a fillet, like a rounded corner, which is something that we can do pretty easily by clicking on an edge and adding a curve like this, like so. If I wanted to, I suppose I should do it on the other side. I keep forgetting that I have 2 parts here. So let me just go ahead and add a fillet on this edge as well, so it matches. Or even let's say threaded. Let's say that this is going to mount on a servo or a motor, but perhaps there's a specific thread, like I'm going to use a bolt to fix that to it. So perhaps I can click on this one and we'll model it. And then we can thread this one. So there's a lot of really great advanced tools, and I see that we've dropped some links on how to use Fusion, how to learn Fusion. So there's lots of great tools that you might want to access by bringing your Tinkercad designs into Fusion, which as you saw is pretty easy to do. There's also a lot of other things we can do in Fusion. Like for example, we could render this. So let's say that your students are designing their parts and they want to present their designs in an engineering notebook or in a slideshow or maybe to their peers about what it might look like in the real world. We can head over to the rendering tab, which allows us to adjust lighting and background and also materials. So I could, for example, find, maybe I'm going to actually make these out of aluminum. I could find an aluminum texture and actually render what these parts would look like if they were aluminum. And this isn't a full high-res rendering right now in the Zoom. We don't have to sit here and wait for a high-res rendering to occur. But again, these are things that we've talked about in the past and really awesome tools for your students to be able to bring their parts into Fusion, see what they might look like in the real world, or even manufacture them, right? So another tab that we can work with is the manufacturing tab. And this is where we might use machines like a CNC mill or a 3D printer or a laser to actually manufacture these parts, right? So, and we can actually, if you're familiar with 3D printing or milling, all those machines operate on a G code file, like a G code file that we would then send to those machines. And within Fusion, there are hundreds of machines that, if I just pull this library up here that you can see, there are hundreds and hundreds and hundreds of machines in the Fusion library, and you could, of course, add your own. So you might be able to find the printer that you have access to or the mill that you have access to, or again, create your own custom machine. So students can actually prepare these designs to be manufactured. And I did one ahead of time. So you can see that I have almost the same part dropped onto a generic 3D printer here. And after selecting the filament that I wanted to use, we could actually see how these grippers might be 3D printed. Again, all done in the same program. So this was our Tinkercad design that we brought into Fusion and then used the different tools to be able to render it, maybe add some new features, or even bring it into the manufacturing space, which is really cool. So all great resources that we have access to, which is hugely exciting. Now, something else that we have access to, and I'm just going to flip my screen here. I mentioned First Robotics earlier on, and there is a fantastic site, which I'm sure we'll drop the link to the chat in the chat in just a second here. So there's a fantastic site where if you specifically are in First Robotics, or even let's say, for example, you're not in the First Robotics competition, but you just want to use some of the parts that you might see in the kit, there's these resources put together by Autodesk where you can actually download the parts that you would get in the First Robotic kits and be able to bring those into Fusion. And you could even actually test and simulate your robots, like the code and all these things as well. So if you design a robot in Fusion, you can simulate that using the First Robotics fields. And all this is free to access, which is hugely fantastic. So let me see if I can bring Fusion back up here. All right, so for example, I have imported one of the wheels. I did not design this. This is a wheel that was imported from the kit, from the First Robotics part kit, and I have a gear here as well. So again, even if you're not part of First Robotics, let's say that you're just challenging your students to build robots, these are some really fantastic parts and tools that are already designed to be imported directly into Fusion. And what students could do is they might make a gripper like this and then actually incorporate and assemble their design with these gears or something. And you could download and 3D print or machine them. So just fantastic resources to model and build. And I'm going to flip my screen one more time just to show you what that simulation software looks like, which I'm not an expert in personally, but it's a really cool space where after students design their models in Fusion, they can actually then bring them into this simulator called Synthesis. So this little robot here that I'm zooming in on was actually designed in Fusion using the parts that I mentioned, and we could actually test it out, test out its functionality, and this field is the official First Robotics field. So this is a really fantastic resource for students to be able to, again, not only build their robots, but test them, simulate them, see how they might function in the real world space, all through an iterative design process like we've been talking about. So really cool resources and why you, again, might want to get your students to this level where they can start to obtain this. So very cool things as we're designing the mechanical systems of robotics. But what about the not mechanical systems, right? So we talked about our different subsystems. We talked about the fact that we have mechanical subsystems to consider and also electronic subsystems to consider. So where will we do this, right? So let me share. We're going to head back to Tinkercad now. So here we are back in Tinkercad, and I'm specifically looking at my circuits projects, and I'm going to make a new circuit. All right, so circuits is a fantastic space where students can design and simulate electronic circuits, which is really exciting and something that we can do and something that, again, we've talked about in past webinars. So while I'm doing a very fast crash course tonight, I recommend you check out those resources. There's so many amazing things you can do. But let's say, for example, I want to design a little analog circuit here. I might grab a battery, and there's plenty of batteries we can pick from in our components. I might grab a switch, and I can rotate my components around like this if I wanted to. Okay, let's grab an LED, and let's design a safe circuit that's going to function correctly by grabbing a little resistor just to make sure that we're making a circuit correctly and appropriately, right? So what I can do is I can actually connect wires between these components, right? So I can make a little red wire connect between the positive of my LED and the positive of my battery, and then I can connect the negative of my battery to the switch, and then wire that to my other components, like a resistor and an LED. And if I were to build this in the real world with these components, I would expect this LED to turn on. And when I press the simulate button, we can test just that. What would happen if I had these components in the real world? Would the current flow? Would we be able to make electronic circuits? And we can see here that yes, I can flick the switch and I can design an electronic circuit, which is super cool. And with robotics, this is fantastic. Students can be prototyping their subsystems, those electronic subsystems. As they design circuits like this, they even, Circuits automatically generates a schematic diagram for them to look at with the schematic symbols, which is really cool. And again, bringing in career connections and things, or even a bill of materials. So it shows them the real materials that they would need if they were to actually build this in the real world. And many of these components you'll find in the 3D editor, not where you can program them or anything, but where you can actually design 3D models around them, like we showed you earlier. So for example, here's the yellow motor that I pulled out in that design earlier, and somewhere in here is the servo motor I pulled out, right? So these components can all be kind of modeled around as well, which is super cool. But with robotics, as we're designing our robotic systems, ones that are programmed to do things autonomously, we might use what's called a microcontroller. So there's a lot of different microcontrollers out there. There's two of them in circuits we can take advantage of. I don't know if you've heard of them before, but the microbit is very cool and a really easy to use microcontroller that students can interact with and program to make things, many different types of robots, maybe ones that drive, or maybe just autonomous systems like a plant, water, or something like that. And we also have an Arduino, which I'll show you in just a moment. So what I could do is I could, for example, grab the microbit, and maybe I grab a component, like let's turn an LED on or something like this. And I could wire my LED to my microbit. I'm just going to flip this around, and I'm going to wire the negative of my LED to the ground pin of my microbit, and then the positive of my LED to one of these positive pins. And then I can actually program this microbit right here in circuits in both a block language or in a text language, which for the microbit would be Python, which is super cool. And students can actually write code. And if they're just learning how to code, you can actually have both screens open like this. So watch what happens if I grab a block of code, like for example, an if statement here. It actually writes that if statement in text too. So I use this when I'm challenging my students to learn text code, and they can actually elevate their skills as they design, which is super exciting. So let's just make something super simple where, like, for example, if I, let's go to our inputs here and see what we have. Like, let's say, we'll do it with the button. So when I press the A button, I want my LED to turn on. So on A button pressed, perhaps I turn on pin 0 like this. So if I run this simulation, if I press A, I'll zoom out here. We have the little microbit simulator to use the different sensors and things in the microbit. When I press A, I'll do that again. I don't know if you saw, but we start the simulation, the light is off. When I press A, the light is on. The light doesn't turn off because I never coded it to do that. But maybe if we make another on and say, when I press B, we can send a low signal, which would turn the light off. When I run this, let's say I press A and the light turns on, I press B and the light turns off. And now this is very, very simple, right? So this is a super simple circuit, but we could elevate this where instead of maybe pressing the button on the microbit, that could be a button on the front of our robot. So if the robot's driving and if a button's pressed, instead of the light turning on or off, perhaps we turn on or off one of these motors. And there are a lot of great circuits for you to look at, like some starter circuits here. So for example, if I head over to the circuit starters, we can see that there's some pre-written circuits for the microbit that I can grab, and I can even see the code of what we have going on here. And I think this one involves temperature. So if I adjust the internal temperature sensor of the microbit, we can see that this servo is rotating and it looks like we are saying we have a little cold emoji if it's cold in the room, a happy emoji if it's a good temperature, and then we start to cry and get a little hot if it gets a little hot here. So this is essentially a microbit thermometer for our room here, and you can see that we have the little LCD screen elevating as well. So there's lots of great resources on how to make these types of circuits built into circuits, which is super cool. And I mentioned Arduino, which I think I have here. So this is like an Arduino one. Arduino is a slightly more advanced microcontroller. And again, just like the microbit, we can program it in text or blocks. I have this written in text, but we could actually program an Arduino in blocks as well, which is cool. So this is a C++ style language here. And this is actually an obstacle avoidance robot. So we have our wheels attached to a servo motor. And when I run this simulation, this is a little distance sensor. You'll notice that we are only 8 inches or 20 centimeters away from an object, so our wheels are not spinning. But when I drag the object farther, the wheels start to spin. So our robot's driving forward right now, and as it gets close to, let's say, a wall, it stops. So we have a nice little simulated robot program here, which is super fun and good to do. So again, right now we are simulating and designing that other subsystem. We talked about mechanics earlier on. Now we're looking at electronics, which is super cool. Now, let's say you want to get the code out of circuits onto your microbit or onto your Arduino. What do? Well, you can press this little download button right here, and you could actually download this Arduino code, and there's the same download button for the microbit. And for the Arduino, you would use the Arduino programming app to actually upload it to the Arduino. And the microbit, you can just drag and drop that code onto the microbit, though that varies a little bit depending on the device you're using, whether it's a Chromebook or a Mac or whatever it is. But you can download your code right from here and then bring it onto your microcontroller. And there's also tons of libraries. So if you are using Arduino, for example, and you want to input stepper motors or an IR remote control, there's lots of libraries that you can work with as well. Now, I'm going to head back to that simple circuit we made earlier on. Hang on one sec. Let me find my documents here and show you what if you wanted to actually bring this circuit into the bigger world and actually talk about manufacturing, let's say like a printed circuit board or a PCB, right? Or how could we elevate this design? Well, I mentioned that there are electronic features in Fusion as well. And there's also the same send to Fusion button that we had in 3D design, but we have it in circuits. So what I can do is I can hit this send to Fusion button. I'll rename this. And again, I could send it to a specific team if I wanted to, but I'm just going to open this in my Fusion on my desktop, which should pop up here. Give it just a second. And now I can see this is my circuit design. And I have the schematic diagram right here. And this is a layout if I actually want to make a circuit board. And we can see that I have the components, which are already built into Fusion's library here. And if I want to customize this and modify it a little bit, like for example, this resistor is looking a little close to my LED, I could drag this down a little bit and I could, when you design it in Tinkercad and you kind of draw all the wires, it might not necessarily be in a good layout if I actually want to manufacture this. So I can adjust my designs, I could simulate my designs, and I can even generate a 3D PCB to see what this would look like if I actually did manufacture it, let's just give it a second here. There we go. So here's what it would actually look like with the components. So here's my LED and my resistor and my switch and my little 3-volt coin cell battery. So students can actually make a 3D model of their circuit and then incorporate this model into their robot design. So if they're designing a chassis of a robot that has to fit these electronic components, they can actually simulate what those electronic components would be, generate a 3D model, and then bring those in with the wheels and the gears and all the things we talked about earlier, as well as actually generating a manufacturing file, it's called a Gerber file, but that's something that you might actually use if you were going to use a CNC mill or something to actually manufacture this PCB, which is very cool if you happen to be an electronics teacher and you want to bring these concepts, these robotic concepts into your electronics class, maybe teach soldering, really exciting learning opportunities that, again, bring in real-world career connections. So with that, I'm going to come back to our slideshow. We went through so much, but we were almost out of time here, and I want to save time for our Q&A. So let me just find my PowerPoint. We have a couple exciting resources that we want to talk about. And first, I just want to remind you that while we did go through all of those things rather quickly, and robotics is so broad, so I tried to cover as many things about robotics as I could in a very brief period of time. Again, we're going to follow up with not only a recording to this webinar, but also these slides where all the links that Nicole has been working to drop into the chat are in here as well. So you'll be able to find these links and things throughout, as well as some images and things to support if you want to actually start to bring these things into your classroom, which of course we hope you do. An exciting thing you might want to consider challenging your students to do if they're going to be considering Fusion, or even something you might want to consider doing, is Autodesk offers certifications for a lot of different things, a lot of different Fusion ones for, let's say, 3D modeling or manufacturing, which would be a fantastic, again, career connection for students to do if they might be applying to a job in these industries and they're already learning these skills in the class. They can get essentially credit and recognition for learning those skills, which is fantastic for them to consider. And as a quick recap of why we're doing these things, again, robotic systems play a huge role in everything we do. Most of the products that you own might have been made with a robot. And of course, you might have robots throughout your home. If you have a robot vacuum, but even an air conditioning unit or a light that detects when you walk by it, those are all autonomous systems. So students have seen these robotic things in the world, but they might not identify that, hey, we could be the people that make them. So if we bring these concepts in, we provide them with these resources, these challenges, these skills, these tools, they can start to think, wait, I could be the person that's solving problems with these robots. And that's not only incredibly engaging, but also a meaningful learning experience and one that might inspire them to consider possible future careers as they really use these tools to design and make anything, which is hugely exciting. For all of you who are here with us, attending this live, thank you so much. In the email that we send with the slides and everything in the next day or so, we're going to include a 1-hour professional development certification for you attending this PD with us. So again, thank you so much for being here. That'll be included in the email. And we have the email from you registering, so don't worry, we have that. So if you're here, we have it, and we'll send this out to you in the next day or so. And before we open up the Q&A, I'm going to bring my co-host back in the spotlight, Nicole, because she's going to tell you about some of the exciting things happening in our Instructables community.
All right. If you're familiar with Instructables, it has a wide variety of projects for people to follow along with, but we also have a teachers section specifically for students and teachers, and you can actually sort the projects by grade and by subject. So you can just look at everything if you want, or if you're looking for something in particular, we've tried to make it easier for you to find. And then also on Instructables, we have contests, and we have a lot of different kinds of contests running all the time, but we also have some student-specific ones to kind of go along with the semester this year. So the first one that we have is the Green Future Design Contest. And for this one, we want you to think about some of the challenges that we're currently faced on Earth and how you can use design to create a healthier planet that we can all thrive in. And you can design and build anything as long as it's about sustainability. And then you need to use Autodesk Fusion during the design process. So it's a good one to do with the older students. And then another one that we have is the engineering in the kitchen. Sorry, I'm trying to drop links at the same time.
I'll take over the links, Nicole. Don't worry about it. Just realized that I realized that you're usually the person doing the links, so I got you covered. Don't worry.
All right, and so this is another one that's going along with the semester. So this is about inventing something new in the kitchen and doing engineering experiments with foods or otherwise applying principles of engineering in ways that are appropriate for the kitchen. So it's kind of fun to be able to bring cooking and food into the engineering space to kind of broaden what you can do and what people think of when they think of engineering. And then next we have made with AI. So as people know, AI is getting more and more popular with what it can do. And so we want to see what you can do, what your students can do with AI as part of their design process and in creating anything. So it could be Chat GPT, or you could be using generative design like in Autodesk Fusion, or just anything that, as long as it involves AI, you can enter it in this contest. And then the last one that we have for that kind of goes along with the semester is the Remake It challenge. And for this one, we really want you to build upon the ideas that have come before, because a lot of people, when they think of making, they think they have to make something totally new and unique, which is fantastic. But a lot of making is about building on other people's ideas. And a popular idea is, you have spoons and you have forks, but what if you put them together? You get a spork. And why not? It can make things easier for you. And so we just want people to be kind of imaginative in what they can make that someone else has already made. And it's nice for being able to make things to fit your specific needs because sometimes you need something a little bit more unique than you can find normally, and someone else might too. So why not make it and share it? All right, and then the last one we have is the Make It Resilient. So this is a big one that we have going on. We are giving away a total of $50,000 in prizes, and this includes two $10,000 scholarships, four $5,000 scholarships, and 10 $1,000 scholarships. Now, this one is limited to the US and Canada, but the other ones are not. And for this one, we want you to imagine how you could design and build a habitat for an extreme environment. And then you also must incorporate an Autodesk software. And so we have this one going on for a little while still, but we hope that you'll be really get really excited about this one. It'll be a good one for students. And then we just wanted to mention that we have different challenges going on Tinkercad as well. So those are fun for younger kids that just want to have fun designing. Right now we have the Aquatic Habitat Challenge, which is about making a habitat that floats or could float in a flood zone. And we have new ones launching every 2 weeks. So maybe there's not something that you like right now, but there will hopefully be something there later.
Awesome. Awesome. Thank you so much, Nicole. Yeah, these challenges are fantastic. And even if there's not an active challenge, like you see, we have the two, you can always go back and check out the past challenges. And those might be exciting opportunities that you bring into your classroom as they engage with these concepts. Again, a lot of real world problem solving and things as well. So before we open up the Q&A, I just want to say thank you so much for all of you who attended live with us here. And again, please expect a follow-up email in the next day or so. A huge thank you to Nicole for being my co-host and supporting as she always does. And also a big thank you to Christian and Darren for joining us as well from the Autodesk Tinkercad team and answering your questions and dropping in some useful links in the chat. So a big thank you to everyone here that's with me, and of course all the other fantastic Autodesk and Tinkercad team members who work so hard to make these resources fantastic. So we hope to see you again in 2 weeks' time for Design and Make with Lasers. Same place, same time. That'll be an exciting one where again we'll kind of balance Tinkercad and Fusion resources. There's so many things you can do as well.